Yep.
Okay, good. So this is cybersecurity outreach. This is a project I put together because of the number of cases of fraudulent activities by young people. And I believe that they are not directing their energy properly. And I believe that eventually they should be able to learn from people like yourself, Chris, and then they'll be able to become better developers and all of that. That's one part. And secondly, I'm also lecturing at the university. So I felt this is an opportunity for them to learn from you as a developer and be able to know what it's like to work in a big company like yours. So for you students, Chris is a senior advocate, technology advocate with Splunk. Splunk is an American company that produces software. It's a Fortune 1000 company with over $2 billion US revenue. It has over 7,000 employees in about 27 offices worldwide. And it is accelerating progress for innovators in IT, security, and Devops. And Chris speaks and engages with end users regularly on behalf of Splunk. So it's a great opportunity to have Chris here with us today. Chris.
Great. Thank you. That's great. And I love that you got all the details down for Splunk, and I'll talk a little bit more about Splunk as we get started here. So yeah, thank you for your time. You know, I love the program. I think that that's really exciting. And I think the punchline for my whole session here is that, you know, as you grow your career as a software developer, you have to think about many things that are outside of the code. And as you do that, you can be very, very successful that way. And I've seen it, and it's amazing. And the industry is changing. The industry is changing how they hire in particular, because you see a lot less emphasis on, you know, long-term, long history as a developer and an engineer, and less emphasis on degrees and more emphasis on ability to collaborate, ability to understand other aspects of software development. So before I fully jump in here, I wanted to give you kind of an analogy that I want you to think about. So this is a McLaren 1 race car. Splunk is a regular sponsor of McLaren, and they use a lot of our technology to do data analytics on the cars itself. So let's suppose you got a chance to drive a McLaren and you sat in the seat and they told you, car's yours, go, do whatever you want with it. But then you ask, well, where's my helmet and where's my seatbelt? And you look in front of you and you see a bumpy dirt road. How comfortable are you going to feel driving one of the fastest pieces of equipment out there in that type of scenario? Now, some of you might be saying, yeah, I'm all about it. I like to run fast and I don't care about the consequences. Well, I think most of us would realize that to go fast, you actually have to think about these things. You have to think about, how do I sustain velocity? How do I go fast in a successful way? That's the reason you have safety gear. That's the reason you have tracks that are round and inclined and all of the things that come along with racing that aren't driving the car itself. And I'm sure as you've had conversations about software development, some of the things that you've thought about the most have been velocity, going fast without really thinking about what does it take to go fast over a long period of time. Now, this is not just true with building applications. This is true with your career as well, because you have to architect your career, just like you architect an application. You have to build your resume and your career to get to your end goal, whether it's an engineering or maybe a specific industry. So I like that analogy, not just because I get to show the race car. And really what you're going to get the most out of me from me today, because my background is probably a little bit different than most of the presenters you have, is how do you really become a high performing software engineer? What does that mean? And how do you think about that in terms of your career path and what you do today? Now, what you're going to discover is a lot of what I'm going to talk about is not code specific, because I have all the confidence that you're a good coder, but you may not be a developer, and you may not be an engineer. Those are two different things. Now I think we have a fairly good crew here. Type them in the box if that's the most appropriate way. And let's keep it conversational if we can. The other thing I'll say is that if I use a term that you do not understand, because we are very guilty of doing this in our industry, using terminology that people don't understand, please let me know, because that is often a challenge and a barrier to having a conversation. So as Ame said, my name is Chris Riley. My title is a senior technology advocate. What does that mean? So I'll describe my history here in a second so you understand kind of the evolution of my career personally. But in the world of application development, and think about how you learn as a developer yourself, you don't trust marketing material typically, and you don't trust salespeople for sure, the typical type of salesperson. What you trust is your peers and people who can explain how to do things in specific ways. That's my job inside of Splunk. So I am the peer to developers inside of Splunk, such that externally I can engage with developers and speak their language and understand what makes up their daily lives and bring that knowledge back into our product organization, but also produce content around it. I run the developer relations program at Splunk, and we create a lot of content, and we also have a lot of fun because we create currently, the current development that I'm doing myself is building little video games around concepts in the DevOps market that we're helping to educate people on. There's a lot of education that goes on in my role. If you're interested to find out more about me, you can scan that QR code. Love to have a conversation if there's anything that specific stood out, or even if there's anything you didn't like. Happy to have that conversation as well. So here's a little bit of my history, and this is not meant to be talking about me and bragging about me, but I'll tell you there are certain patterns that people fall in their career development. And it's become very clear, especially as I've been doing mentorship. So in 1997, I created an IT startup here in Colorado, which quickly evolved to be kind of a outsourced software development organization. Very early days. The models for that type of business were not yet established, especially in IT. It wasn't very clearly established how to work with organizations. And if you're familiar with that time, tech evolution was just crazy fast, right? It wasn't like now every time they release a new phone, it's a bigger screen and a faster processor. Like, things were radically changing every single year. So from there until around 2003, which this startup is what paid my way through college in Colorado, I got a CS degree focused on genetic algorithms. And if you're not familiar with genetic algorithms, they're basically an over-engineering of most problems. They're a really fun machine. Go ahead.
Yeah, Chris, you just talked about how you paid your way through college using money made from your startup.
Mm-hmm.
Wow, that's great. That's great.
Yeah, it was all grit. And I think that grit is an important trait to have as long as it's channeled to the right place. But yeah, the company was called IntelliKey, and it paid my way through school. Yep. Wow. So I got my computer science degree with an emphasis on genetic algorithms, a technology I fell in love with. And if you have experience with it, it's a very, I don't know how else to put this. Like it's a very sexy technology. Like it's a really cool what you can do with genetic algorithms. The reality is most of the things that genetic algorithms can solve can be done with statistics. You don't need genetic algorithms. So although the algorithm itself is awesome, it didn't really have a place. And at that time, what I did is I built my own SDK and I tried to sell it. And I wasn't successful. So instead of going down the path of continuing that startup, I decided to branch out and join as a developer to an OCR company called Abby. Abby's one of the top OCR, optical character recognition engines out there. And I was a developer on the core OCR algorithm. Now, those two relate to each other. It's also, again, based on machine intelligence. You had some neural net and image processing and stuff like that. And it was very, very cool. My job was to integrate that into the SDK because we sold an SDK that people could buy and integrate OCR into their products, and they are still running today. So around 2008, I took that knowledge and I created my own OCR startup. A company by the name of Artzel. They're actually still around as well. And I went from being fully the dedicated developer of our product to leading a team of development. So that is where I started to get more of my experience on what it means to operate in an engineering team. And it was a lot more fun. It's way more fun than developing in a silo. There's a lot more energy that comes from working in a team, and you learn a lot more and you become better at your craft. But that's how I slowly realized that, and this is where I use the term bad coder, that compared to the developers, the coders that we brought onto our team, there was no comparison. I was good at application architecture, but I wasn't the best developer. And there's a lot of reasons for that. A lot of it has to do with I'm not a very detail-oriented person. So when it came, I produced a lot of bugs. I could produce good prototypes, but I created a lot of bugs. And I kind of understand where that came from. So I started to move into the business side of things. And the natural evolution, if you're kind of a developer and you want to move into the business side, you might move into product management because you still help to determine the backlog and the ticketing for the product. And you have to define the features in a technical way so that engineers can take it. Then I even went a little bit further there and moved into marketing. And the reason I did that is because I was really good at explaining deeply technical concepts like OCR, optical character recognition, to technical audiences. I've always been in this area where I'm selling to technical audiences. So a developer for developers versus a developer for some consumer. And that is a very important point that I will touch on later. So I moved more into the business world, but still in kind of the intelligence technology community when I helped build a natural language processing engine, which, by the way, is very similar to an OCR engine in many ways. Yeah, go ahead. If you have a question, why don't you go ahead and type it in?
Someone raised that.
I saw a hand raised.
Yeah.
It was raised. Maybe it went down.
So,
so I went from there. And around that time, this whole idea of Devops started to form. So it was originally created by Patrick Dubois, not created. That's a really wrong way to say it. Nobody can create smushing two words together. He made it a thing. And then it really became a thing beyond him when Gene Kim wrote the Devops handbook. That's what made Devops a business thing. And I jumped on that. I was one of the first 5 authors of Devops.com. Now, granted, before Devops, there was application release automation, application lifecycle management. These concepts were always there. And from day one, we've always been wanting to release software faster. So it wasn't new, but it was a better approach at bringing those into enterprises. So I became a DevOps thought leader, and that's kind of where I hang my hat today, for good or for bad. That's what I speak on. That's what I get invited to speak on and end up on podcasts on. After that kind of grew, I started this company with two other co-founders. So this would be the third of my startups, called Fixate. And Fixate is basically what I do today at Splunk as a service. We would sell to companies like Atlassian. Splunk was a customer. Sumo Logic was a customer. Datadog has been a customer. All of the kind of big vendors you can think of in the development space were customers of ours. And what we did is we helped them with technical content creation. And we also created a site called sweetcode.io, which is a media site, and potentially an opportunity for you all to share your knowledge if you want to write for this site as well. So I did that for 7 years. It was a successful business. It was a lot of fun. The most successful of all the startups that I've had. But 2019, I decided it was time to go back into the vendor world, and I joined Splunk, who was a customer of ours. And I joined in this area of advocacy. So what do I spend my time doing? I spend my time engaging with external community, bringing that knowledge back internally, and then also building out all of this great content like our interactive games. And it's extremely powerful. And my background and what I'm going to share with you is not just my career history. It comes from tons of interviews with engineers in large companies and small companies, in cloud native companies, in on-prem companies, and all the patterns that are there. So I know that that was a little long-winded, but really the punchline here is that as you think about becoming a better engineer, I'm going to say, you need to go beyond the code. And you need to think about becoming what people call as a T-shaped individual, or you've probably heard the term soft skills. You need to think about how to gain other skills that are not just writing code. And you need to embrace the SDLC. SDLC stands for the software delivery chain. I want to cover some terminology, and some of these terms I will double click on, but they're terms I'm going to be using. So I'm going to fly through some of these. DevOps, we're going to talk more about. CI/CD, we're going to talk more about, but CI/CD is the automation for delivering your code from when you commit it to your repo to when you get it in production. Microservices, that's the new application architecture that people are using. Instead of building monolithic application, they're building individual services that comprise a bigger application. So what, shift left. This is go ahead.
What's the difference between monolithic and microservice?
Yeah, that's a really good question. So monolithic applications tend to be compiled applications or running on a JVM like Java, C#, C. And while the application itself, the code, has functions inside of it, which you could consider a service, when you deliver the application, you have to deliver the entire application in full. Microservices breaks that paradigm in that each aspect of the application, it could be a shopping cart, it could be one button. If you look at Amazon's homepage, there's about 120 microservices that comprise that page. It could be a button, could be recommendations, could be ads, whatever it is. Each one of those can be released independently. And each one has its own development team, has its own stack, and is building independent of everyone else. They don't care when they release their components. They are in control of theirs. So they can release 10 times a day where somebody else is releasing once every 2 weeks just for that page. And so that's the difference between monolithic and microservices, but it also implies things like Kubernetes and Docker. Okay. Shift left. This is the idea that we move considerations that used to happen solely in production earlier in the delivery chain. GitOps is the idea that you drive everything from your repository, your infrastructure, your application, everything is scripted, everything comes from your repository. You may have heard this also as infrastructure as code. DevSecOps is the idea that we bring security considerations into the development process. Site reliability engineering. This is a new role that is now an embedded IT person in the engineering team. Observability is the new term for monitoring, is the new term for how you monitor your applications in production. But it addresses the challenges of microservices applications. And then I want to talk about the difference between being a coder versus a developer versus an engineer. So a coder is somebody who can write code and can write code really well. And it could be, you know, full object oriented. It could be scripting with Python in Jupyter. Like there's a wide range of coders. Most people, when they start in the world of development, start as a coder. And that's a lot of times where what they learn and where it ends. But a coder is not a developer. So what's the difference between a coder and a developer?
Okay, I have a question here.
Sure.
It says, it's asking, what languages do you need to learn to be a cybersecurity expert?
Well, I think that this is an interesting question because coders and developers also a lot of times think in terms of programming languages. It's always changing. It will always change. There is never going to be a point where you say, I've picked this language, I'm done, and there's never going to be another programming language. Like through my career, I've developed become a professional coder in 3 different languages. And now those languages are not the standard. However, most cyber analysts use Python today, but that's going to change, I'm sure. So Python is a very good language to learn if you're wanting to get into cyber analytics. Or
someone has a question here. He said, you said you paid your tuition fee using funds generated from your startup. I would like to know how easy it was for you to build your startup while you were in school.
Yeah, I actually have a whole section on creating your own startup near the end. So I will address that question then. Okay, go on. But the punchline is it wasn't easy. And no startup is easy. It's never easy. And like I said, I've had arguably 4 startups in my career and only one was profitable and I would consider successful. My first one was moderately successful, but my last one was the most successful and I changed my approach. All right. So coder versus developer versus engineer. This is important for the rest. A coder writes code. They understand how to write good code. A developer understands the workflow of building applications as well as writing the code. So they understand how to use repositories. They understand Agile. They understand what it takes to release your application. So beyond the code, an engineer is one step further, starting to get into the business side of it and looking at the overall architecture of the application and thinking further ahead into the future. So I see this as a career progression as well, because it's important to go from coder to developer for everybody on this call. That's important. It's important to get those skills. But if you're really going to advance your career, you wanted to get into the area of being a true engineer, which is thinking outside your code, your functions, etc., into the bigger picture of what your application means for its end users. A few of the things that you can do to be a better coder. Well, first thing, and again, think of this as an evolution. First thing is you need to understand that the quality of your code is a feature of your code. So you think about the feature is the feature that you're writing. That's true. But if that feature does not operate correctly, it has bugs, it has vulnerabilities in it, then that directly impacts the application. So when you develop, you need to think about quality, not as that extra step that you do as a grooming thing. You need to think about quality as an actual feature, because your end users expect quality. If you don't deliver quality, then you're not delivering good functionality anyway. So it doesn't matter how cool your feature is. If it's not written in a quality way, then you're not delivering to your end users. The second thing of just being a coder, know how to log, high quality logs, know how to write logs, know the structure of your logs, know how to be consistent in the logs that you write, because this also gets to the support of your application. And you are the first step in making sure that your application runs well in production. And you shouldn't neglect that. That's not somebody else's job. That's your job. They might be supporting it, but you're the one who creates the context for what happens in production. Let's see, there's a question.
Here. Yes. Do you mean that those that want to be data analytics or scientists should focus on Python programming language?
So today, yes, but I want to go back and reiterate something. If you think that you're going to learn one language and you're going to be done, that's not going to be the case. You also need to learn how to learn languages. You can't just focus on one language. You can't. I've never known an engineer who has been one language their whole career. That's not true. I do know a few, but it's very niche jobs. For example, if you're building integrations into Salesforce, you need to know JavaScript. That's all you really need to know. And you can stick with JavaScript if that is your niche job. But if you're an engineer over a long period of time, the programming language you use will change, guaranteed. So also learn how to learn languages. And that's part of being a better coder. Now, the next step in the evolution is being a better developer. And to be a better developer, you need to build your application as if you're the one who's on call for it. You're the one who has to support it. You're the one who's going to get woken up in the middle of the night if it stops working. You need to understand agile processes and something called PI planning. PI planning stands for product increment planning. So you're going to use that to drive your backlog, your ticketing system. You need to use a ticketing system. If you're not already using a ticketing system to create a backlog for your application, then you're already not yet in that developer category. That is part of being a developer.
Okay, could you precisely, let's answer this, could you say precisely the problem you face and how you were able to overcome them? Of course, I understand you might not face issues like electricity, internet, and the likes due to support your country provides. But how were you able to raise capital? You see, the students are really interested in you having a startup. And yeah, I know that is great because you all are computer scientists and you want to learn how to turn your ideas to product. But what Chris is saying here is very important as well. And if you don't get the foundation right, you may not do well, because he already has the experience. He started up about 4 companies already. So it's not about starting up something. It's about being able to make it outlive you. Do you understand? Or to be able to give services to people like he finally learned how to do. And that's what he's trying to tell you people now.
Yeah.
So it's
I will dig into the startup part and I can get there faster, but what Ahmed is saying is absolutely correct. You will not be successful as a founder and with a startup if you don't become an engineer. So if you're a coder today, if you classify yourself as a coder, you have to be an engineer first. And there's things that you have to do to get there. It's not writing code specifically. So yes, that's exactly correct. Thanks for the summary.
Thank you.
All right. So let's say you want to be a founder. Yep, I've had 4 companies, and my first one was successful. What does that mean, successful? Successful really should mean, now in the tech world, success can mean users, but success really should mean you're making money. because ultimately we all want to make money. So if there isn't money somewhere at the end of your product, like there isn't the objective of getting money, it's going to be very difficult. Now, in the early days of VC funded startups, all you needed was users. That's it. That's all that matters. And that can be really easy. But a lot of times the platforms that drive a lot of users are the ones that can never make money. So you always have to think about, how am I going to make money? So my first startup was directed at making money. And it was a services business. And then we started to add software development capabilities. I was never really interested in being a services business, but it's the easiest business to make money early on. What is a services business? A services business means you don't have a product that you're charging a subscription or a license fee for. It means you're selling your skill set essentially on an hourly basis, time basis, or whatever. There's different ways to do it. So services business are the easiest way to make money. From my perspective, not the most fun. I much prefer to have a product company. So the first thing you have to tell yourself if you want to build a company is that your product, your coding is only 20% of the journey. And if you think that you have a great product idea and you can put it into code, I'm sure you can. I think everybody out there can learn to be a developer. And one of the questions is, where do I start as a developer? It's kind of a loaded question because I don't know what your focus area is. There's different types of developers, like front-end developers are different than back-end developers, et cetera. So you need to have some sort of focus, but you can learn to develop from YouTube. There's coding camps, computer science degrees are a great place. Udemy and all the online coding schools are actually really great to become a coder. You can become a coder. It's much harder to become a business person. It's much harder to know what it takes to make something that people actually want to buy. That's what you have to learn. And I hazard to guess that's where most of you need to, it's going to be the area for greatest development and perhaps more challenging. The biggest mistake I see technical founders make is that they have an idea and they've never vetted that idea with anybody. So they get an idea in their head. They think this is a great idea. I should make an app. I can do that. I know how to code. I'm going to do it. They create it and they never vet it. And by vet it, I mean they never run it by somebody. They never get somebody else's input. Now, there's one reason that they do that. They're scared of what's going to be told to them. They don't want to be let down. None of the startups I have created have started with the original idea. None of them. I had an original idea. It never became what that original idea was. It was some version of it, but it never actually became that original idea. So you have to be able to pivot, because the reality is that your original idea probably has holes in it. It has flaws. I was going to say every idea has flaws. Those who are the most successful are the ones who have the grit to get the hard criticism about their ideas and change and pivot, because it happens everywhere. PayPal was a massive pivot. Like most of the massive startups out there were pivots. Where they actually made money was not where they originally started. So you have to be comfortable with that. And the only thing that it takes grit. Like everybody I've seen that has gotten through this is they get the wind knocked out of them, by getting hard advice and criticism, and they kept going. Those are the people who are most successful. And if you keep on going, and if you produce meaningful skill sets and become an engineer, not just a coder, then you will be successful in some way. So my second startup that was a big failure, cost me a lot of money, happened in this way. I failed to look at competition. I failed to look at other developments in the industry that were going to make the solution that I thought was the end all be all solution, which was document scanning in the car. essentially. So it was built for truck drivers. When you're a truck driver, you have to fill out time cards. Getting those time cards to the place that is determining what you get paid is a lot of effort. You have to mail it. So my system did this all in the truck itself. You filled out the time card, you scanned it, and you see the relation to OCR. You scanned it and you send it off and reduce the time from weeks to days. Well, that's right when the mobile phone was coming out. And I failed to think about and think through the process of what it takes to make something physical and software, because it was a physical device and software. Why is the system logging? And physical device and software. And I didn't think about like the business side of it. And I didn't get the hard criticism that I should have gotten early on. So you need to think about that. The other thing is that technical founders tend to start too big. And they always want to talk about everything their product does, which might be important to you, but may not be important to the end user. So you have to figure out what's important to the end user, because all of the secret sauce that you think that makes your product great is probably not the same way that the end user perceives it. And you may learn very happily that what they're interested about is something very simple. So just do that one thing really, really well and forget about your secret sauce. Just do that really, really well. Launch with that, make it the best it can possibly be, and then start to add new functionality. So this is typically how it goes when you want to launch a product. You start with your idea. That's usually where technical founders stop, is the idea. And they leapfrog all the way to, why isn't it successful? Why didn't I win with this product? It's because you didn't do the rest. From the idea, you have to create user stories. So forget about implementation. How are your users actually going to use it? And does that align with reality? Have you actually talked to users and they told you that your assumptions are correct or they're wrong? User stories are the best way to work into your functionality. So a user story might be, me as a user, I want to click a button and get this result. So again, forget about the code. The code is not going to save you necessarily. You have to think about what the end users want. You have to be obsessed with your end users. Then you might create mocks, and I graded out here because sometimes there's reasons to jump right into building the application versus creating mocks. Mocks are mock-ups. Sometimes your idea is complex enough that you have to create mock-ups. So once you go from there, you need to start to create a backlog of functionality for your MVP, minimal viable product. And it should be very, very simple. It should do one thing really well. I'm building a new application today, and this is the exercise that we're going through. What is the minimum thing we can do to satisfy the needs of our end users? Then you find what are called design partners. These are people who have said to you, if you can build this product and it works the way you say it's going to work, I will pay you money. If they don't say the last part, then you need to think, what is the business model here? Why am I doing this? A design partner is a future customer, and they become design partners by working with you to build the product and maybe getting it for free or whatever. They get some incentive because they are working with you to help make sure that it's the best possible product. Once you have 2 or 3 design partners who are actively using your product and you can reference them as a case study, then you launch, and only then do you launch. Most startup founders go from idea to building it to launching it in an app store. And then they get frustrated why nobody's using it. That's usually how it goes. You skipped everything in the middle, and that middle steps are absolutely critical. And how you get to those middle steps is everything we were talking about before that you can't gloss over, which is you have to go from being a coder to a developer, and from a developer to an engineer. Because, and I'll just share these slides so that everyone can have them. An engineer thinks about the customer. An engineer thinks about the business. An engineer thinks about beyond the function that they're writing into how that function represents itself to the end user and impacts the overall organization's goals. Because technical founders can be their worst enemy because they neglect competition, they neglect marketing, they neglect the business side of it. And the best idea will fail. It can be the best idea in the world if you don't pull these other things together. And it's difficult. And one way to do it is read articles about startups that you love, that have been successful, see what their journey was, but also startups who have failed and why did they fail? And it's very interesting when you follow these stories because they almost all follow the same pattern. Like in Israel, there are a ton of startups, but the success rate, of course, like of any startup, is not very high. So what is the difference between one and the other? And it all has to do with approach, making sure you understand your customers, because most people try to launch a product which is only slightly better than a product that already exists. That's what happens a lot. And it's really had to have an original idea. All right. As a part of developing your careers, I use this term called code to cloud visibility. What is that? That is thinking about weaving a thread from the point you define a feature in your backlog to the point that feature is running in production, weaving a thread all the way through to establish continuity. And what I mean by continuity, I mean that you have, what's it called? You have an audit trail of everything you did to build that feature all the way into production. Why does that matter? One, it matters because that's how you're going to learn where your gaps are. But two, it matters because if you are truly going to be successful, you can tie what happens to your application in production back into your backlog. I'm sure that you have all seen the infinity loop of Devops. But a lot of times people don't think about infinity loop means that you learn from what happens in production. And you need to take those learnings and improve your product from it. And that's what I mean when I say customer obsessed, focusing on your customer. What features are your end users actually using versus the features that you deployed that they're not using? That matters. All of that matters. So I like to think about code to cloud visibility in everything that I do, from the point of feature is defined, to develop, to committed to repository, to built, to running in production. Engineer, defining features, building functionality, testing them, building in quality. They can see it. In the last 2 years, I've unsubscribed from 2 services, both of which had the best content. One was a remote learning program for my girls. One was a fitness program. I unsubscribed because the quality of the software was too bad. So they had the best quality content, but the quality of the software was bad. If you remember, I said earlier, quality is a feature. So when a user touches your application, they are judging you as a developer. That feels really uncomfortable. They're actually deciding how good a developer you are. You, as a technical-minded person, have probably used an application and thought to yourself, the people who built this weren't very good at their jobs. So what is that? What is that? What is that thing that allows you to identify a good application versus a bad application? It's not how well they code. I promise you it's not how well they code. Every engineering manager out there is going to say, I hired good developers. It's something else. It's because they don't think about the end users. They don't think about the end result. You should work backward from the end result. All right, so Nokia, you raised your hand. Please type the question in the box. That's going to be, I think, easier. let's see, if I have an idea but don't seem to understand programming really well, can I start up a company and employee develop? Yeah, I mean, of course, if you're good at strategy, if you're better at strategy than being a developer, that's fine. What you need to be careful of, and this goes to what we haven't talked about and we may not get a chance to, but I'll come back if it makes sense, which is security. Outsourced developers, like any contractors, they don't love your idea as much as you love your idea. Nobody will. And so they're not going to give 110%, which you're going to give. They're going to give 80%, which means they might cut corners. Most people cut corners when it comes to application security. And what that means is they store passwords as clear text in a database. That's many applications have failed because they outsource their development or they hire developers that cut corners in security. They release packages, they use open source packages that have known vulnerabilities. That's very easy to catch, known vulnerabilities, but they still deploy it. And delivery chain attacks are on the rise, by the way, on the rise in a big way because of SolarWinds and et cetera, et cetera. So you need to be an architect. You need to understand what it takes to build a good application, even if you're not the one building the application. I have people in my neighborhood who ask me, Chris, I have a great idea. I'm going to go and hire an outsourced developer. And I say to them, that's great, but you need a technical founder first. If you're not going to be the technical founder, you need one, because the technical founder will be able to catch potential risky behavior in building the application. So that would be my recommendation. All right, there's more questions. Please type. Okay, they vanished. So catching those security risks is what we refer to as Devsecops. Devsecops means you bring security considerations earlier in the delivery chain. It's a big conversation right now. Organizations are spending a lot of energy thinking about this. And some of the stuff that is done is very basic. For example, I've seen organizations who put passwords in their commit messages in their repositories. So those passwords are widely visible, or store their passwords on a file and deploy it with the application, or allow the developers on the development machine to do whatever they want without consideration that what happens on the development machine might happen in production. Especially with Docker, I can, as a developer, be working on a container that has vulnerabilities and somehow get that container into production. The way you fix that is using container registries and having a vetting process for containers before they make it into production. So this is really important. It's something that a lot of us don't want to think about, but you also don't want to be the developer who's caught releasing a vulnerability. Not that you're going to lose your job, because most organizations have embraced this blameless culture, but it doesn't feel good, right? You want to contribute to the success of the product, not get the product in a situation like what happened with SolarWinds, where you're spending months and months and months addressing a vulnerability and not building new functionality. By focusing on security today in your code, you reduce the risk of being shut down and prevented from building new functionality for long periods of time, because developers always just want to build new functionality. So do the things now that will prevent you from stopping that, if that makes sense. And that again goes to the car analogy. Make sure you have your helmet and your seatbelt on so that you can drive the car fast, because if you don't have those, eventually it's all going to stop. And that's just basic things: how you write your code, how you test your code, thinking about technical debt. A lot of times developers will intentionally create technical debt today, telling themselves they'll address it tomorrow, but they never do address it. So if you have that mindset, before you commit your code, if you took the fast way, the easy way out to write your code, clean up your technical debt before you commit it. Code quality, vulnerability scans. This is scanning your code for known vulnerabilities. It's very easy to do. There's a product called JFrog X-Ray, as part of Artifactory, I think today. Scan your code, see if there's known vulnerabilities. If there's known vulnerabilities, update those packages. That's it. Very straightforward. And repo hygiene. Don't just keep on creating new branches. If you want to create a new branch, think about it. Why are you creating a new branch? Do you actually need a new branch? Is there a better approach? Because rogue branches in your repo pose a risk to you. You may accidentally use them. They may have known vulnerabilities again. Make sure you're clear on how you're using your repositories. There's other best practices, but the most important thing is thinking about security from the point you define a feature and when you write your application, because I assure you, it's going to allow you to actually move faster, not slower. Feels like you're going slower, but it will actually allow you to build more and move faster, because if you don't do it, you will eventually get interrupted as you move forward. So I want to pause there for a second. Ame, how do you think we're doing? Because I know I've crunched a lot really early on, but is there anything that you feel like I should double click on?
Yes, a lot of them, I believe, as you're aware, they're still students, and the others that are joining us are people that are trying to move from a different field to coding and software development. So that issue of not just being a coder or a developer, but being an engineer, I really want you to talk about it, because I think that is where we have a problem here. A lot of us are not disciplined enough to want to go through all of that just to, we're thinking, okay, we could just get things done, or we could get, we could just download open source applications and just use it. So I really want you to talk about that.
Yeah. So I'm going to say something that's kind of interesting. Your impatience is a benefit. Like, it's good. Your impatience is good. Wanting to be lazy, I'm going to say something radical. That is good as well. DevOps is about being lazy. DevOps is about building automation so you don't have to do the work.
Thank you. Thank you. Thank you so much for that statement. You know, I read somewhere that Bill Gates likes giving jobs to people that are lazy because they always find the easiest way around it, as in how to resolve the issue. And I think I like that too, because I don't like working really hard. But it's not, for me, I don't think it's that easy to come up with something really good at the end of the day. You still go back and work, but you think it through generally.
Yeah, and lazy is not a replacement for strategy. Because if you're truly lazy, you spend 80% of your time strategizing, because in that strategy, you are thinking about how to do it the most efficient way. You're thinking about how to do it the best way. You're thinking about how to do it in a scalable way so that you don't have to redo it. Because what most developers ends up happening is they refactor and refactor and refactor, and then they end up with a monster of a code base. But if you think about it ahead of time enough, that won't happen. You will not waste that future time. There's a term called opportunity cost. The biggest cost you will ever have in your career is opportunity cost, because of things that you didn't think about, you didn't anticipate. Those are the things that will kill you. I'll give you an example. There's a product that I was intimately involved with, and we didn't think about single sign-on. We just built the application very, very quickly, got all the great functionality. Certain types of companies loved it, etc. You cannot sell a product today to an enterprise without single sign-on. It's not a fun feature, not at all, but it's also not easy to develop. So because of that, we lost so much business, and we had to spend 6 months building in this functionality. Everybody stop everything and just build single sign-on. Nobody wanted to do that. If we thought in advance, we would have realized, the people we want to sell to require this feature. So let's build this feature today, because if we build it tomorrow, it's going to cost us a lot more opportunity. This is a lot of fun. So that's just one example, that if you're truly being lazy, you have to be lazy in a strategic ways and lazy successfully, which means you spend the time thinking in advance. How do you do that? Well, there's a concept called writing narratives. You can document your architectures. You can create reference architectures. You can test your ideas with other people. If people only say yes to you, then you're talking to the wrong people, or you're asking the wrong questions, because people want to validate. We all want to be friends. That's human nature. So we always want to say yes, but you might be asking the wrong questions, or you might be talking to the wrong people if that's what you're getting. And if this feels discouraging, that's okay, because again, it's the grit. The people who have decided to power through, it's the grit that gets people through those challenges. Yeah. Well, so I want to kind of wrap up here, because a lot of the stuff that we talked about is conceptual. I'm going to share the slides, and hopefully they all get in your hands and you review them, because we glossed over the transition between coder to developer to the engineer. We didn't spend enough time there. And that really matters, because being an engineer means that you're not just thinking about the code you're writing. You're not just thinking about the product you think you want to launch. You have to go beyond that into understanding the business side, the architecture, the metrics that you're going to measure it by. Usually, you should understand what success looks like before you even start. Sometimes we call it a North Star. What do I want this to be? How much money do I want it to make? My last startup, the very first thing I said when I wrote the formation papers for the startup is, I'm only doing this if it makes money. That's it. And it did. It's been the most profitable startup that I've ever created. So there's a lot more to it. And what I want to do to kind of appeal to you personally is to say that may feel boring. It may feel tedious. It may not feel comfortable and fun because it's not code. Code is only fun for a while. What really makes code fun is when you're successful with it. And success doesn't come from writing code. It comes from everything that takes it, packages it up, delivers it, and the customers love it. And so if you spend energy on that, you will have more fun. Once you get good at it, you will have more fun building your applications, because eventually, once you have a product people love, you get to do cool things like feature flags and neat stuff where you can do experiments. You can be in a position where you can actually do experiments with your functionality at a very low opportunity cost. But the foundation has to be there. You have to be platform minded. You have to think bigger. Always think bigger. As soon as you think that you're thinking big enough, think bigger. And so it's not easy. It takes grit. And you have to be able to handle criticism, and you should welcome criticism, because if somebody is critical of what you're doing and you can still convince them, then you have something. When a lot of times when I was doing stuff and I had meetings and I was trying to sell things to people, I would always try to find the most critical person in the room. And I would tell myself, if I can convince them, I've already convinced everybody else. I only have to convince that person. So if I address their concerns, I've done it. And that tends to be true when you're launching a product. So you should see that as an opportunity, and don't be afraid of it. And those uncomfortable feelings of feeling like it's too much or the letdown, and it's going to happen. And if you look at any of the founders, it happens. Disappointment happens. It's getting through it and sitting with it that is what separates one person from another.
Yeah. Thank you so much, Chris.
Can you just code for fun? Absolutely. If you don't want to make a job, then find a way to use code to automate a job. Like that's what a lot of machine learning people have done to be successful. Use it to make it your job. Like automate something fun. I know a professor in the US who was a professor of French history. And what he did was build an application around the history books and maybe learnings from them. I don't even fully understand, but he used code to do his job better as a French history professor. And that was just for fun. I think this question of how do you start coding, I guess the easiest way is to, there's a lot of like online coding camps and there's free ones, etc. If you have access to, you know, some of these fun tools like iOS has playgrounds. You can code in playgrounds. Minecraft, you can code with Minecraft command blocks.
Okay, thank you, Chris. We're almost out of time. Want to say thank you. I know the internet is unstable right now. I will get in touch again. I really enjoyed today's webinar, and I want to thank all of you that joined today. And remember, your assignment would only be marked if you were a part of this webinar. So I want to say thank you to everybody. Thank you, Chris.
Yeah, thank you. Have a great afternoon, and I'd love to come back. Evening.
Thank you. I'll definitely invite you again. Thanks. Bye.